Let's take a look at lesson 7 on page 42, using inductive reasoning. Now, inductive reasoning is simply the process of reasoning that a rule or statement is true because several specific cases are true. And so it's really just using logical common sense to figure out what the next step would be, is all inductive reasoning is. Inductive reasoning can be used to formulate a conjecture about something. And a conjecture, definition of that is a statement that is believed to be true. And the best thing to teach this is just using a couple of examples. So example 1 in the book says formulate a conjecture by looking at the pattern to see how many blocks will be in the 5th arrangement of this series. So we have the first arrangement, we got 1 block. Second arrangement, 3 blocks. Third arrangement, 3, 4, 5, 6 blocks. 1, 3, 6. Okay, well, let's go ahead and build a pyramid here and see how many blocks we think will be in the 4th figure. Well, we notice that each bottom row and vertical row, the length and width, increases by 1 block every time. So I'm going to add a 4th block and then fill in the pyramid. So what we find is that in the 4th drawing you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 blocks. Well, you could formulate a conjecture without even drawing the next one. Notice that first one goes from 1 to 3, so it goes plus 2. Second one goes from 3 to 6, plus 3, 6 to 10, plus 4. So we can make the conjecture that the next arrangement in the blocks will be plus 5, being 15 blocks. And you could draw that out if you wanted to, but that would be a conjecture. That's an example of using inductive reasoning to find a conjecture. And there's one more example we'll go ahead and look at. This is actually in the practice problems. But it says it says form a conjecture about the next value in the pattern. And I put 3 values there. We go from 1 to 1, 2, 3, so on. So what we got to figure out, okay, what is the logical inductive reasoning that we are getting from here to here and so on and so forth? What is a conjecture that we could make? Well, a conjecture that we could make is, in order to get from 1 and 1 to 2, I'll go ahead and just give you the secret. In order to get from here to here, we are actually adding those 2 together to equal 2. How we get to 3 is 1 plus 2 equals 3. 2 plus 3 equals 5. 3 plus 5 equals 8. And so the conjecture would be you add the 2 previous numbers. So getting to the end, 21 plus 34 is 55. So this blank would be 34 plus 55, 89. This blank would be 89 plus 55, 144. And we'll skip that blank. But the conjecture answer would be the value that comes next in the sequence is found by adding the 2 previous values. But that's all inductive reasoning is, and that's how you formulate a conjecture within that. So that's lesson 7. Moving on to lesson 8 in the book. Just looking at a couple different formulas, just refresher. You have seen these formulas before. Lesson 8 formulas. First one is perimeter. That's just the distance around a figure. So if we have a polygon and a closed figure here, if I was creating a formula for perimeter, and we know that it's the distance around the figure or the sum of all the sides, sum of all sides, if it's a polygon, then what I could say here is length plus width equals the perimeter, aka 2L plus 2W equals perimeter, and that's just the simplified version. One quick example, just to use a couple of terms that we've used in geometry the last few lessons. Example 1C says you have a regular pentagon with side lengths of 8. What is the perimeter? Well, it only gives you one side, gives you 8, so that's obviously critical. But then it has a couple key words in the beginning. Regular. What do we know that regular means? Regular means that all the sides in the pentagon are equal. All the sides are equal. And in pentagon, you just need to know how many sides are in a pentagon. 5 sides in the pentagon. So we draw what is obviously a regular pentagon. Know that all the sides are 8. 8 times 5 sides is 40. So your answer there would be 40, whatever the measurement is. Inches, 40 inches. Moving on to area. Area is, definition, is the size of a region bound by a figure. So if you have a quadrilateral, a 4-sided polygon, how do you find the area of that? Well, the formula, as most of you know, is length times width, or base times height. So in example 2, if we're finding the area of this polygon, or this quadrilateral, you would simply do 14 times 3 and get your answer of 42 centimeters. Now, since you're actually multiplying centimeters times centimeters, well, we don't want to write centimeters times centimeters. We just go ahead and write centimeters squared. So your answer for your area for that problem would be 42 centimeters squared. Last formula to look at in this lesson is simply the Pythagorean theorem. And the Pythagorean theorem is a squared plus b squared equals c squared. This is only for right triangles. Only for right triangles. If it's obtuse or acute, you cannot use Pythagorean theorem. A and B in the Pythagorean theorem are the legs of the triangle. It doesn't matter which one is which. These could be swapped. This could be A and this could be B. It does not matter. The only thing that matters is that C is your the only thing that matters is that C is on the opposite side of the equal sign as the A and B, because it's the hypotenuse. Hypotenuse is always opposite of the right angle. Otherwise, you would mess it up. So if we're trying to find, in example 3a, if we're trying to find x, the hypotenuse, we would just plug this into our Pythagorean theorem. 12, 5, those are both legs, because that's a right angle. Those are both legs, so we would do 12 squared plus 5 squared equals, I'm going to go ahead and call it x squared since that's our variable. And then you solve. 12 squared is 144. 5 squared is 25. Those added together are 169 equals x squared. Okay? And how do we solve for x squared equals 169 and get x by itself? Well, we got to do the opposite of squared, and that is to square root. When we square root, those cross out. Square root of 169 is 13. So 13 centimeters would be x. 13 centimeters would be x. We'll do one more example. Example 3b says find the area of the triangle if this is 3 feet and this is 5 feet. Now, something we haven't talked about yet is the area of a triangle formula. should know it by now, but triangle area is 1/2 base times height. That's your area. 1/2 base times height. Well, we're given this triangle, and we have a height, but this is not the base. This is the base. So we cannot solve for this yet. We have to figure out the base. We would have two variables otherwise, of A for area and B for base. So we just used the Pythagorean theorem to find a missing side for the hypotenuse. You can use the Pythagorean theorem to find the missing side for a leg as well. So we would plug in 3 squared plus, make sure you do b squared equals 5 squared. Make sure your hypotenuse is opposite of the A and B, opposite of the legs. So then we solve. 9 plus b squared equals 25. Subtract 9. That's 16 equals b squared. Just like we did in the last one, you square root it. Square root of 16 is 4. So 4 is the base. Now we know the base and the height. Base is 4. Height is 3. Plug that in our formula. A equals 1/2. 4 times 3. Let's cut the 4 in half. 1/2 times 4 is 2. Times 3, 6. It's area, so feet squared. 6 feet squared would be your area. And those are the formulas. It gives one other formula in example 4. We don't use that much, just from converting Celsius to Fahrenheit. But if you need to look at that for a problem, you can just look at that formula, because all you do on these is plug it in. But that concludes lesson 8.